With this video, I will show you how to search for spectra, and in particular IR spectra and GC chromatograms. In front of you, you see the Chem 306A online guide. If you click on the Spectra tab, this will give you resources for finding spectra and finding specific GC chromatograms. When you're looking for spectra, there's a number of different resources that you can use. For instance, we have access to SciFinder. This is a subject-specific database used for searching for chemical information. If I quickly go into SciFinder and show you how to find a IR spectrum, this is the front page of SciFinder. If I click on substances and in the search box typing the name of a substance, say caffeine, click on search, this retrieves all substances that contain the term caffeine. The one I'm interested in is at the front here. Now at the top on the left side of each substance there's a number. This is the CAS registry number of the substance. If I click on it, here you will see chemical information about your substance. If I scroll down a little bit, you'll see this table with headings from other names and identifiers to additional details. These are linked. If I click on the heading Experimental Spectra, you will see all the different spectra that have been reported for your substance, from NMR to UV visible. If I click on IR, these are all the different IRs that have been reported, and next to the IR is the source. You can access the source from the source list directly. If I click on one of these, say View Absorption Spectrum, this will bring up the spectrum of your substance directly, and you can download it or email it to yourselves. Okay, so if I go back, there are also other resources that you can use for finding spectra. For example, if I click on ChemSpider, this brings me up to the front page of ChemSpider. Now there's a search box here, so just type in the name of your substance, click on search, and this brings me up to the chemical information of the substance. If I scroll down a wee bit, I notice there are tabs from names to more. If I click on the Spectra tab, this brings me up to all the different spectra that can be found from ChemSpider. If I click on infrared, here you see all the IRs that have been reported for caffeine. Let me click on one of these, and this brings up the infrared of caffeine. If I go back, I can also look in PubChem, so let's click on that. Again you see a search box, so just type in the name of your substance and search. This brings me up to a link on caffeine, and these are different synonyms for the substance, so just click on that. And here you will see the page with information, a lot of chemical information on caffeine. On the right side you see a contents section, and the contents section headings are linked to the actual page. If I scroll down a wee bit, I notice there's a heading spectral information. If I click on the downward arrow, you'll see all the different spectra that are reported in PubChem. Okay, let's see what we can see. NMRs, mass spec, there's a GC mass spec, UV spectra, and there you have it, the IR. So let's click on that, and this brings me up to the different IRs that have been reported in PubChem. If I click on one of these, let's click on the first one. It comes to here, and there's the IR spectrum. Okay, if I go back, there also is the Spectral Database system. If I click on this resource, here I need to click on this button to accept or agree to the disclaimer and use of this resource. This resource provides a number of functionality to conduct your search. You can search by specific spectrum here. I'm just going to type in the name of the substance and click on search here. And this page shows you the types of spectra that are available for this substance. It's got mass spec, carbon 13, NMR, IR. These ones are not available, but I see there is an IR, so let's click on Y for yes, and here you have the IR spectrum of caffeine. Okay, let's go back. If I try one more resource, let's try the NIST Chemistry WebBook. Click on that. This brings me to a page that allows me a number of different search options. If I select name, then type in the name of my substance, I can select the type of thermodynamic data or other data. Here you can see the different types of spectra. Let's click on search, and this brings me up to my substance page. If I scroll down a wee bit, I can select a number of different spectra here. There's one for IR and there's one for GC as well. Let's click on the IR spectrum, and this brings me up to the IR spectrum with a number of different links. You've got the instrument here that's used to run the IR, so let's click on that, and here you see the IR. If I scroll down a wee bit, I can click on image of digitalized spectrum. Let's click on that, and there's the image of a digitalized spectrum. If I go back, I just want to click on the gas chromatography, the GC chromatogram. Let's see what happens. And this goes to a page containing the conditions, setup and run of the GC. So here you'll have the column type, the phase, the temperature and the index. And each one of these is linked to a reference. So this is one set of conditions, this is another set of conditions, and so on. And at the end, you'll find all the references. A lot of these are actual articles, so you can find their information, the chromatograms, from these articles. Okay, if I go back, so you can find spectra from a number of different resources. Not all of these resources may have the spectrum that you're looking for, so you're going to have to do some searchings in order to find the one that you're looking for. Now, an alternative approach to searching for spectra involves searching for the synthesis of the substance, utilizing databases such as SciFinder, Scopus, Web of Science and Google Scholar can uncover relevant synthesis information. In many cases, articles addressing synthesis include the characterization of the substance through spectral information. This is often found in the experimental sections. Some articles may even provide a supplementary or supporting documents containing detailed spectral information, including the actual spectra. Further, if you have a specific spectrum in mind, you could refine your search strategy by using terms like the name of the substance and the type of spectrum, for instance, caffeine and GC chromatogram. So let me go to Scopus and SciFinder and just show you how you can find a spectrum. I am now in the library website. To access a database, I can click on the databases icon. I can then go to the A to Z list and select S for SciFinder or Scopus. Scroll down a bit, there's SciFinder, there's Scopus. Let's click on Scopus. I am now in the Scopus database. Let the scenario be that I'm searching for a GC chromatogram of caffeine. In the first search box here, I will put the name of my substance, caffeine. I will then add a search field. This will bring up a second search box, and there I will type in GC chromatogram. Between these two keywords, I'll select the Boolean operator end, click on search, I have now retrieved 10 documents. Now I can browse through the documents, and if I don't find anything suitable, I can go back to my search strategy and then rearrange my search strategy. Perhaps remove the term chromatogram and just leave it as GC. Then click on search. And now I have found over 800 results. That's a bit too many to read, so I'll need to refine my search strategy a bit more. Perhaps under the field option for caffeine, select article title. Click on search. And now I have 121 results. If I want to, I can refine the second keyword, GC, for article title. And now the database will search for those two keywords in the titles of all the documents. So let's click on search. Okay, I've now found 16 documents. If I browse through the documents, let's see if I can find something of interest. This might be interesting. Oh, this one looks interesting. Development of a rapid method for the determination of caffeine in coffee grains by GCFID. A fully validated approach. So let's see if I can find the full text of this. Click on the Find It button. So this document is available from these different resources. These could be publisher site, other databases or repositories. It also is available through this link here, Get PDF, so I can get the PDF directly. I would like to go to one of these resources and see if there's any supporting or supplementary material that comes with the document. So let's just click on PubMed Central. Usually if there is some supporting or supplementary material, there'll be a link. And I don't see any link. I can go straight to the PDF. see if there's anything stated there as well. At the top I see the PDF link here, so let's click on that. Okay, so this is the full text, and I'll scroll down to see if I can find the actual GC chromatogram. Okay, so there you have it. There's the GC chromatogram. Chromatograms of caffeine in a standard solution and in a coffee grain sample. Okay, so that's pretty much it. If I go back to SciFinder, so now I'm in SciFinder, and I can do a similar search in SciFinder under references by just typing the few keywords, say GC chromatogram caffeine, or I can select title under the field option here and put in my keywords here to search for those keywords in the titles of all the documents. I want to use a different scenario here. Say I'm searching for the synthesis of caffeine. So I can again put synthesis caffeine here. SciFinder allows you more functionality. You can look for reactions and substances. With substances, as I mentioned in the previous video, that you can search for the substance and retrieve the spectra directly from there. You could also search under reactions. So let me just click on reactions, type in my substance, caffeine, click on search, and now the database has retrieved 1,691 reactions. On the left side, I'm going to select product, and now my substance is found in the product of all the reactions. So this is the preparations. I found 219 results. I can refine it a little bit more. I can perhaps say all of them that have 90 to 100% yield. And now I've retrieved 13 reactions. Under expand scheme, I can just click on that, and that will give me information about the source for this reaction. This one's a patent. I want an article. This one's an article. Now I'm looking at the title, and I don't see the title too useful, so I'm going to go to the next one. This one's a patent. This one I'm not interested in. Let's try another one. 2 patents here. Okay, let's try another one. I don't like this title either. Let's go down a bit. It's a patent. Okay, this one looks interesting. A novel method of caffeine synthesis from uracil. Okay, so let's click on the full text for this one. Find it at CSUF. And this document is available from this resource. It looks like this is a database. So let's just click on this. So here you see the full text of this document. I'm scrolling down to see if I see any experimental information. Okay, there's the experimental section. I'm looking for caffeine. Okay, there's caffeine here. So this is the way they made it. See if there's any data, any spectral data. Okay, and this is what I found here. We've got the melting point. It's got the IR NMR peaks match well with the literature values, and they've given a reference, okay, and they've given you the major IR peaks and the major NMR peaks. Now, in most documents or articles, the spectra is written up in a notation format. You don't often see the actual spectrum, but it's giving you two references as well as the major peaks. So if you scroll down a wee bit, these are the two references that contain the literature information on the IR and NMR of caffeine. And these are actual print resources. We don't have these, so you may have to request them from Interlibrary Loan. Okay folks, well, this is pretty much it. Let me go back to the online guide. Finally, I'd just like to mention that I have added some tips for finding GC chromatograms, much of which I've already talked about. If you have any more questions, don't hesitate to send me an email, and here's my email address. That's it folks. Thank you for listening.